Hello. Whoa, hey, hello. How are you guys doing? Sorry about that. How is everybody doing? Now you're completely awake after lunch, right? Very good. All right, a couple of quick announcements that they're making me do up here. So voting cards. Please be sure to fill out your voting cards and drop them off at the registration desk. Because I just was adjusted. Sorry about that. Okay. We're good? All right. Voting cards, be sure to fill those in, drop them off at the registration desk in the front. Also, some of the presentations are starting to show up on the SATURN website. So if you're interested in seeing PDF versions of those slides that are available for publishing, you can find them on the website, the program website from the abstract. Is there anything that you guys have seen today that piqued your interest? Or perhaps something that you'd like to learn more about? Nothing? A little few nods. Very good. Or maybe there's something completely missing from the schedule that you just think we should be talking about? Hopefully not, but maybe, right? Open Spaces is right around the corner here. Feel free to go check it out. Talk about what you guys want to talk about. Bring some friends with you. Have a great discussion, right? So I very much encourage you to try out the Open Spaces as well. All right, so our next keynote speaker is Joe Justice from Scrum Inc. I met Joe a couple of years ago at the Agile conference, and within about 30 minutes of meeting him, he had me, along with a group of volunteers, installing shocks and tires and a carbon fiber frame on a sports car. All right, I had never touched a car before in my life. All right, in terms of manufacturing or building of any sort. Right, could barely even check the oil. But here I was installing shocks. Pretty darn cool. So Joe's the inventor of the extreme manufacturing process, and he teaches that to companies throughout the world. It's also included in several business school curriculums now. Joe has been featured in Team Wikispeed, has been featured in Forbes at least 4 or 5 times. He's also spoken at numerous international venues, including today here with us, SATURN 2014. So, Joe?
How's the sound? Is it good? It's audible? Hi guys, I'm Joe Justice. I'm a business process consultant by day. That's what I do. I do Scrum training, a particular type of Agile project management. And nights and weekends, I run a car company, Team Wikispeed. If I miss a question of yours that might come up during the Q&A, you can reach me through the email or the tweet stuff there, including sending heckling questions during this presentation, especially the Twitter feed, because all of Team Wikispeed, the car company, monitors the Twitter feed, and you can say, Joe just said this, is that true? And you'll have a bunch of other people who can reply with yes or no, whatever. We build ultra-efficient commuter cars. Our first cars were absolutely derived from race cars because honestly they're simpler and they're much lighter. But we did it in a fraction of the budget of what most companies do and in a fraction of the time of what most companies do. Here's our cars, and we treat them like software. When we build a car, we instantiate them. As long as they meet the contracts, the architecture that we did define up front, we use contract first design, we know that all of the 8 pieces of that car are going to be interchangeable with every other car we've ever made. That means you could ask a question like, is it a gasoline, a biodiesel, an ethanol, a CNG, or an electric car? And the answer is, sure. That's a swappable module. It takes about 5 minutes to change. Is it a roadster or a pickup truck? These are all roadsters. Mine's that orange one, by the way. This is a rendering, but that is what mine looks like. The 8 pieces of the car, each, our definition of done is that we're able to assemble the module in less than 5 minutes. So there's the aeroshell coming on, and the last wheel, and the intakes. That's about how long it takes to put them together if they meet the contract. What that also means is we can develop new versions of the modules every 7 days. We work in 7-day sprints. We author the test first. We build something that passes the test. We validate against the test, and we refactor to make it a more durable solution, because typically the first thought to pass a test is not always the one we want to go to market with, but it validated the idea. Then at the end of the 7-day cycle, we complete the iteration. We build it into all of our cars. This is one that was built by Lockheed Martin in California in January. They put it together in 6 45-minute sprints to train their space systems group. They had lost the contract to resupply the International Space Station to SpaceX, a company that also treats a lot of its projects much more like software, even though they're in hardware, even though they're building rockets. Lockheed Martin knew that if they were going to compete with Elon Musk and the rest of the group, that they would need to think very differently, because he was undercutting their contracts to supply the International Space Station by half. So to train their space systems engineers, they built a Wikispeed car, and then somebody bought it, which was kind of cool as the result of the engineering exercise. Here is our joint venture manufacturing facility in Renton, Washington, right by one of Boeing's plants. Here, the individual modules are made by Scrum teams. So teams of 4 to 5 people make modules, and they put them together. And it's not allowed to be called done until it passes the integration tests, that when it's been connected together. That way we don't have people saying, well, my part worked and your part didn't, right? They're not allowed to be done until it's part of the cohesive whole. That way they own it. We finally gave this process a name. I was very shy, too. I mean, it's exciting stuff. I love this stuff, but I mean, we're standing on the shoulders of giants. Almost everything we do was learned from Kent Beck and the extreme programming movement, Jeff Sutherland and Ken Schwaber and Scrum, all the authors of the Agile Manifesto. All we did is switch each mention of software with customer visible value and use the same techniques. That way we could use them in hardware or anywhere else. But we called it extreme manufacturing, to thank Kent Beck and the XP community for extreme programming. The idea of pairing, swarming, and starting with tests, and having a clearly defined contract and definition of done. Our backlog boards look very similar to Agile software teams, but we add columns depending on what type of work we're doing. So carbon fiber work has specific tests for carbon fiber. Do we have any void content? Are the plies laid correctly? Do we have strand orientation along our load paths? Whatever applies to that domain. And cards that don't have carbon fiber skip that column. Whereas if you have a software team, almost every card that they work on, which is their increment of their work, their user story, would go through a column that would be all integration and regression tests passed, deployed to the server. Well, carbon fiber parts don't deploy to the server, they deploy to the garage. So there's a different column for carbon fiber parts. That way we're able to have very different types of work flow together, and we're able to know our velocity, or how quickly we get those cards done, and tune them each sprint. Using Lean, we use a value stream map, and we see how fast our flow rate is. Or we use Kanban, another process for this. We found the waste products from making our cars was a lot of foam. Since we make new carbon fiber shapes for our car exterior every week, every 1 week sprint, we make them out of foam. So it's very inexpensive to mill the mold, and it's a recyclable material. Well, we had all this extra foam every sprint. We found we could maybe, in CAD, knock them down into micro houses for the homeless that would be hyper-insulated. And if it worked, a human occupant just laying in there would generate enough body heat to raise the temperature inside the micro house 20 degrees Fahrenheit over the outside temperature. And we thought that would be cool. That'd be a social good. Let's try to do that. So we did, and this was the first prototype. And it has a Wi-Fi thermometer on it as a prototype. And yeah, it worked. We got 23 degrees higher temperature inside than outside with one layer of foam, which was our waste product for manufacturing. Now we're testing doubled up, seeing if it just scales or whatnot. And we have a water sanitation and hygiene team working on a micro, very cheap composting toilet to try to make these things for $100 or less, so we can deploy them to emergency areas or people where they don't have access or choose not to have access to traditional homes. This caught the attention of the guy who invented Scrum. Scrum's the team-based method of getting the work done, and we use Scrum. Jeff Sutherland. Dr. Jeff Sutherland ran the first Scrum team in 1993 and then worked with Ken Schwaber to figure out how to repeat it elsewhere. How do you write down what he'd come up with? And it's become 70% of all teams that say they do Agile, this way of thinking, say the way they do that way of thinking is with Scrum. So it's become the dominant Agile method. So Jeff called me up, and I was starstruck. Like, the guy who invented the process we're using called me. And I'm really happy about it. And he said, let's run a class together. I'll teach Scrum, and you can show how some of these pieces fit outside software. I was starstruck and said, sure, that'd be great. And we did, and he hired me. So that's me with the Scrum Master he chose, Christine Higgerty. And gosh, Jeff works with Scrum teams all over the planet. He spends 3 weeks out of 4 on a plane somewhere, and now I do too. That's the downside for working. But he gets to pick whoever he'd like pretty much to be his Scrum Master for his team, the person who helps foresee roadblocks and get them out of the way before they affect the team. And as far as I can tell, Christine Haggerty is the best Scrum Master in the world, although now she's just changed to being a product owner for the team. For more information on everything I'm saying, the company has put it in open source on scruminc.com. You can see the white papers behind the processes I'm going to dive into a little bit and how I think this works in hardware. I gave an online course not long ago. I think it's still posted for free. There's some content that's like $50 to access. But anyway, that's the site to dive deeper into this if it's interesting to you or someone you know. Here is an example of how this Agile hardware stuff works. So during the day, I fly around doing Scrum training, setting up Scrum teams, and at night I build cars with Team Wikispeed. Here's Tate Radio in Christchurch, New Zealand. After the Christchurch earthquake, a lot of the companies based in Christchurch were rebuilding their infrastructure and seeing if it made sense to do business the same way, because they were rebuilding their infrastructure at the same time. They build this, the P25 base station. It takes a radio signal in, decrypts it if it has to, cleans the signal, boosts the signal, re-encrypts it if it has to, and broadcasts it out the other end. It's about the size of a 4U server rack. They flew me to New Zealand and with Tim Meyer. You can see his nose right here. And they said, you get to be here for a week. What do you need to help teach our team Scrum? And we said, well, let's try to build the next version of your product. How long does that usually take? They said it takes about 3 months, the fastest it's ever been. We sent out our spec for a circuit board change. It arrived back in 3 months. It worked the first time we deployed it. But usually it takes us 2 to 3 years. For hardware revs, that's about what I bump into at most companies. That seemed normal. We said, we get to be here for a week. Let's try to do it in a week. And they go, oh, yeah, sure, let's try. We'll need everyone involved from idea to delivery of this base station in one room for a week. So you can't have that. These people are on 10 different projects at the same time. Most of them don't talk to each other. We said, I think I know why it takes you 2 to 3 years. Can we try it for a week? They said, yes, we can try it for a week. So they all got in one room. So we have people with soldering irons and soldering hoods. There's a pick-and-place circuit board building machine. There's the software to code architectural diagrams of the chips that they then etch, etc. In this room is even the person who shrink wraps the box and ships it. We put them all in one room for 1 week. On Friday, they had a proxy customer, one of the sales reps, use the product, and it worked, and they shipped it. They did it. They did it in 1 week, which was phenomenal. But then the people on the factory floor said, well, right now, you send us a new design every 2 to 3 years. We shut down over the holidays and we retool to make that new product. If you're going to be sending us a design every 7 days, we'll never make anything because it takes us more than 7 days to change the line. And it's down the whole time. They were already doing lean good practices. They already had a stand-up meeting with their Kanban, their large visualization, their sign in the background with magnets saying, here's what's ordered, here's the current state of the order, here's how it's flowing. How are we possibly going to deliver in 7 days? We said, well, try using Scrum. And they relaunched with a product owner and a Scrum Master, and they changed their Kanban to a backlog of all the work they wanted to do, not just orders. So they put a card in the same backlog that said, reduce the time it takes to change over the line. We didn't know the answer, but we knew it was important, and we put it in the backlog, and they worked on it a little bit, and a little bit, and a little bit, and they put it through each week until they got the time to change over the line to be one morning. So now Monday morning, they come in, and they get the new design that was put through hardening tests, hardening simulations over the weekend, and they call their suppliers, they reorganize the line, they put the machines on casters, they slide them in and out of the line. It used to be one person knew how to reprogram the circuit board pick and place machine, and their busy week was the holidays when they would change over the line. Well, now they would always pair with somebody, so everybody in the team could do some of the reconfiguring, right? Following the hardware pattern of if it's important, socialize the knowledge, and if it's important, make it visible. So now they were able to make, in mass quantities, the parts that were being designed in one-week iterations, as in this case it was Scrum teams. Now, they used to test 1 out of every N parts. And they would actually put them in a temperature-controlled chamber so it would stabilize size, and they would have a electronic measuring system, a CMMI, check the dimensions of the part, and then check logic and continuity tests through all the circuits. If they're changing every week, the defect rate would skyrocket if they weren't doing test-driven development. So now they have this guy fold in cardboard and foil tape a test fixture. And he'd walk over to the line, and they can see each other. They're 20 steps away. And they would nest the circuit board in the cardboard, and someone on the line would swing down a boom with 2 probes. It would run a continuity test and a logic test to see if the circuit board was good or not, red light, green light, and it would go through the line. Then they would see if the cardboard held the circuit board in place. If it wobbled at all, they would take it back, fold another piece of cardboard, bring it back. The person on the line who does the work would say, yeah, that holds it in place. I'll get good test results. Then this guy goes to this CNC milling machine behind him, and he takes a block of aluminum that costs about $40, and he machines the same thing he made in cardboard, the stub that he made in cardboard. He now instantiates it. And then he walks back to the line, and they have a test fixture that will last all year if they didn't need to make a change to that circuit board, but it was only $40, so they can change it the next week if they need to. With this, they're able to do test-driven development. They're able to test every circuit board on the line and test the design, and they start with a failing test and then build the cheapest thing that passes the test. With that, their defect rate stayed as low and actually even went a little lower, even though they were changing designs quickly. Then, at that time, they had 1,500 employees. They invited 1/10 of them, randomly selected, choose 1 out of 10 people from your department, and send them to the big room. They had 150 people in a ring from all levels of the company, from the COO to the janitor. And everybody said, in 30 seconds or less, one thing they'd like to change about the company in the next week. They then voted on it, and it happened. Because they had everybody from the COO to the janitor, there was no one to then approve it or no budget process to go through. They just did it. I mean, the budgeting team was there. It was done. And in less than 15 minutes, they had one small thing they were going to do to change the company in the next week. By doing that every week, the entire company was agile. They reduced the cost to make change. So if Motorola came out with a game-changing product tomorrow, they couldn't be more than 1 week out of date or irrelevant. They could make a small change every week. Not every company is ready to do this the whole company-wide. They did. It was awesome. But teams at a time do this all the time. It's called the retrospective in Scrum. Or departments do this through Scrum of Scrums. Or whole companies do it through this method. When we came up with the idea of naming something extreme manufacturing, we knew it could have implications for many different industries. In our case, Scrum design teams working with Scrum manufacturing teams found they had to use object-oriented architecture. If whatever they were working on was designed as a monolithic whole, upfront ivory tower design or architecture, it was expensive to change. Whether there were Scrum design teams or Scrum manufacturing teams or not, it was still expensive to change. What they bumped into is whatever it was they were making, software or hardware or both usually, needed to be split up into usually less than 10 pieces at the top level. And they had to be very clear about the architecture about how those pieces would connect. Once they knew that, they could iterate all of those in parallel, all the modules, all the pieces. Then the company is never more than 7 days out of date or irrelevant. In Team Wikispeed, all the work we do to build our cars and innovate our cars is put in a backlog. It's a list of sticky notes. In this case, it's a virtual list of sticky notes, and that's our URL. So you can look at what we're working on now, if that's interesting to you. That let anyone in the world complete our work. We made it an open source project and a nonprofit because we were getting more velocity from people we'd never met than people we had met or were in our offices. By having our work as a public URL and doing something kind of fun, like building ultra-efficient 100-mile-per-gallon cars, people wanted to do it in their spare time. So we might have a backlog item that says, refactor our cruise control algorithm. Well, our cruise control is running on an open source piece of hardware, an Arduino, a $28 circuit, using a programming language a lot of people know, processing. It's a derivative of C. So people all over the world would check into our GitHub and try things. And because we started by writing a test, if you pass this test, we know it's done, they knew exactly when they were done. We never even met them. And then that card goes to done. More velocity from people we'd never met than people we knew. We're now more than 500 team members in 20 countries. The team in the Netherlands, I just got to bump into them in person last week, and they're now doing this to do modular yacht building in Holland. That was a very early demo video. The car didn't even have a body yet then. It was an aluminum box on wheels with an engine. It was the simplest thing that met road legal safety specs. It had an airbag, not much else. Side crush structures, front crush structures, and that's it. We film demo videos every Thursday, whatever the state of the project, and we insist they're less than 5 minutes each. That way, people can see the current state of the project or dive back into the history easily. There's shops in 20 countries, so sometimes we have a lot of different demo videos, but they're all less than 5 minutes. It's easy for people to see in any time zone what the other people did because they're recorded, and we just put them on our YouTube channel. I do work with companies that do this with sensitive data. They put it on a private share. Same technique, though. From this demo video, way before we thought our product was done, while it was still iterating and evolving in its 8 modules, somebody bought one. And we got a flood of investment. Really? The car's not, it doesn't even look like a car. But some people were ready. And so by just making it visible, we were able to organically fund the project all the way through. Right now, the entire company is funded by people who go to our website and donate $10 a month through us through PayPal. There's enough donations to run shops in 20 countries now. And we run it as a social good nonprofit, ultra-efficient commuter cars. The first car we ever built took 3 months from design to on the track, and it was hideous. We called it the orange shoebox. It had a NACA airfoil front, you might not be able to see from this angle, but also a NACA airfoil tail and an aircraft canopy. And it did meet road legal safety regs, and it did post over 100 miles per gallon. So we got, and it sat 4 adults. So we got road feedback early, way before there was anything pretty enough to even talk about. But then the car was invited to the largest auto show in the world, Detroit, Michigan, January 2011. This was about 6 months later, and we panicked. What are we going to do? So we iterated the aeroshell to make something more beautiful, and then we started accepting Bitcoin to buy our cars, and we were put on the cover of Bitcoin magazine, which was a lot of fun. And we got a flood of orders, and we weren't able to keep up with our orders. We had to formalize our teams to be faster. The secret of Scrum is you accelerate teams. They deliver more per week by removing what's in their way, removing impediments. So we created a log of everything that was frustrating the team or making them unhappy or slowing them down, and we started working on them. We tried to remove at least 1 a week. From that, and that's the Scrum Master's job to make those visible, we were able to have the product owner and the team members accelerate their work, and we were able to start keeping up with orders. Then we had to be more disciplined about pairing and swarming, practices from the apprentice system and the German Machinist Guild, but then formalized and made very lean by extreme programming. And there's two folks, Kurt Roy and Martin Val, building one of our engines, and they're able to share information with each other as they build. So every time we do anything in team, we request at least 2 people do it, and information propagates through the team. We don't have any time for training. When someone joins the team, we don't have an introductory video. We don't have any 3-ring binder of documentation or policies. They just join someone who's been there at least 1 week, and they build a customer's car. And at the end of that, they're usually proficient enough that they can be someone else's pair next week. Then we got this rendering from Rob Moorbacher of More Composites. We're like, that's gorgeous. Rob, let's build that. We took a vote across the team, and we decided to build it. And we did. We unveiled it in January 2012 at the Agile Alliance gathering in Texas, the largest Agile conference, this way of thinking. Agile is a culture. How do I reduce the cost to make change? This conference for people who had that culture or wanted that culture, it's the largest gathering in the world, Agile and then the year. So in this case, it was Agile 2012. They had us do the closing keynote, and we unveiled the car. And that car was built backstage in 2.5 hours by people who'd never seen it before. They pulled from a backlog of items what are required to put this thing together enough to get it on stage. Here's the swarm of people working on the suspension. Sorry, in this case, the chassis. They're drilling holes in the chassis to be able to accept the suspension. And I just stepped back to take this picture. Here's our Scrum Master from the Seattle shop at that time, Clayton Osterman, and our intern from Turkey, Emre Aras. And they're assembling the 4 suspension modules. And in the back, Tom Tabor, who leads Wikispeed Las Vegas, is working with a swarm of people putting decals on the carbon fiber car body so it's ready for display. Then I did a red edit, Ask Me Anything, saying, we build a 100-mile-per-gallon car and placed well in the X Prize. Ask me anything. And that ended up being some of the most effective marketing we've ever done. So we completely abolished any sense of something like a marketing spend and said, instead, we'll share the most clever or most interesting things we think we're learning and let that be our marketing. And we got a flood of orders and investment. Then we replaced all electronics on the cars with Arduinos. They're about this big, about the size of a deck of cards, and they're $24, the version we buy. And they're open source, so people were able to easily contribute to all of the electronics of the project. Then we thought, let's package everything we think we're maybe learning into, we called it a black belt class. We said people will learn how to work with aluminum, just enough to build all the parts of the car we make out of aluminum. They'll learn to work with carbon fiber, just enough to make all the parts of the car we make out of carbon fiber. They'll learn to program Arduinos. They'll learn how to run wiring and connect wiring so it's weather tight. And they'll learn how to make interiors out of white faux fur, because that's awesome. And we'll do it all using Scrum, so by the end they'll know how to work as a team pretty easily if that's what they care about. And then we'll build a car together. And then they'd done every aspect of the process we thought was important, because they'd built a car, and we called them black belts. Said if there is such a thing as an extreme manufacturing black belt, that's you, because you started with raw materials, you rolled a car out the other end, and you did it all as teams who'd never met each other before, and they did it in 4 45-minute sprints. Is it repeatable? Can it be taught? That's what I care about, because my day job is trying to teach this stuff. Is that real? Here's what we bump into. John Deere sent 3 managers out to my garage, which was very embarrassing, because my garage is a messy garage. And they participated in a Thursday night build party, which is a funny way of saying we drink a lot of beer and change 1 or more of the 8 modules of the car. And they did it. And they drank a lot of beer with us, and they helped build part of the car. And they said, yes, let's do it for our tractors and combines and our next-gen products. We're like, cool, let's find out if that works together. And they flew me out, and we did do training across the teams. And 16 months have gone by now. And they track their velocity every sprint. That's a required thing for Scrum teams to do. Not all of them do it, but they should. or else it's hard to tune. It's like tuning for top speed and not knowing how many miles per hour you're going. So they did track their velocity from sprint 1 on, and they saw with the same people and the same number of people, they were now delivering 7.2 times the amount of work per week as they did before when they started. They said it's the single most effective improvement in their process they've ever done, which is cool, right? So maybe this can work. The same employees are now outputting 7.2 times as much work as they did before, and it took them 16 months to get there with one experiment, one change in the way they work every week. Each week they do a retrospective, make one change to speed up and be happier. Then they said, well, this worked in our headquarters in Moline, Illinois. Will this work in other offices? So they tried it at their India Innovation Center 3 months later, and in 13 months they hit 5.6x velocity. That team is a team of 5. Here's why. Measuring velocity across teams worldwide, we see a statistic trend. 4.6 team members on average delivers more work than any other team size. So the teams are all 4 to 5 people, and when they have a project that requires more than 4 to 5 people, we say no problem, we'll be going 7.2 times as fast in 16 months. But also we say, sure, spin up another team alongside. So we'll have multiple teams of 4 to 5 people, and they coordinate through what's called Scrum of Scrums. So maybe it wasn't even culturally biased, because they could do it in the United States and in India, but they wanted to try other sites. So they tried it in their Germany office 2 months ago, and they hit double velocity. That's about average. That's about what we see. And then in Indaiatuba, Brazil. And then Boeing called. And we said, well, okay, maybe this does work. Maybe it's repeatable. This thing we're doing as a hobby after work, nights and weekends in my garage and in other people's garages and a few pro facilities, but it's really like a hobby project, like a club, Team Wikispeed. Maybe you could use it in your company. And then Raytheon started doing this, and I'm not allowed to say which groups, but I can say it involves the missile systems and space systems. That much is public. And then Xbox One, and then HP Labs and their next-gen shipping containerized server farms. And then TomTom in the Netherlands. Their dashboard navigation, and this is kind of awesome, this watch navigation came from one of the Agile teams. They bought an Android watch and deployed the TomTom OS onto the watch. It's totally cool. And the team Xabia there is all using these methods to now help share this with hardware companies. And TU Delft does hydrogen electric car racing. And they started using a backlog for their 2-year car iterations. They would make a new hydrogen-powered electric car in Holland every 2 years. And they put it into a backlog and found they were able to knock out a lot of the time. Because when it's a prioritized list and you just pull the next most important thing as a team, it goes much faster. And they made a demo video.
Over the years, the way which we planned projects has completely changed.
It was quite hard to start because you didn't begin from scratch.
I brought Joe over here to the Netherlands.
We decided that it would be time for a change in terms of how are we planning projects, or how are we going to approach the next couple of months.
Their current iteration speed is about 2 years from a new idea to getting to deployed and tested. We'd like to see if we can get that to half the time. Then we'd like to see if we can half that again.
After we had kind of a car with all the systems inside already, but so many bits and components to work on, we needed to have some more interactive view where everybody in the team knows exactly what's going on in all of the other departments.
For that, we use Scrum, and that's why I was invited here by Xabia. Xabia, here in the Netherlands, uses Scrum to improve the performance of many different businesses worldwide. They brought me in to see if that technology could be applied at some of their hardware clients, and we got to hang out with the engineers here at TU Delft to see what might accelerate them. They've been using pieces of lean product planning and some of Scrum for the last 3 weeks. They're getting ready to do their first Kaizen, or their first retrospective, to see how they're going to tune it to go faster.
Started having whiteboards with post-its on it, and then decided that it was a really nice and interactive way of planning our whole year and every week of our project. And well, so far it's going great. We're learning more every day, and the boards become more interactive every week.
He gave some tips about our Scrum method, and I think it was very useful. I think we can speed up the process due to him.
Working with Xavier has been fantastic to bring hardware Scrum practices to Xavier's already advanced software Scrum practices. With teams like TU Delft and the hydrogen electric car racing team, we get to see what can happen when very fast-moving teams iterate in hardware. Now, putting Scrum in it, we think it might go even twice as fast.
By using the Scrum method, you can do awesome things like zero emission racing, and that's the thing that we need to innovate. And by doing that by racing, he really liked that.
That video was 3 minutes long. They were able to cover that much information. They film one of those every week. That's the idea of the demo video, to cap a sprint, to show what got done that week. It took them 3 hours to film the demo video, and then they did have a team member who was good at video editing, and they added all the dramatic music and that fun stuff the next day, and they posted it. So imagine if every project you're on had a demo video like that weekly, and it doesn't have to be that dramatic and polished, but if that's fun for you, go for it, or if you're in a funding round, go for it. And everyone knows the current state of the project every week. Then I got to meet a school that's doing this, K through high school. They teach every subject using Scrum. The students come in, the bell rings. I was talking to the professor. It happened to be a science class for high school students at that time. And they pull out their backlog and they say, what is it we need to learn today? And they pull the stories across and they do their retrospective. How are we going to learn more today than we did yesterday and be happier doing it? And then the students start going through industry periodicals. It was the molecular algebra of glass that day. So they're looking at glass journals, and they did have a textbook. And then they give a demo to the teacher, and the teacher says, please go a little deeper here, or yes, that's perfect. They did it all as teams. And then the teacher whiteboarded for about 10 minutes. The students came up, took pictures of the whiteboard, rearranged their sticky notes, and did more work and left. The prof was involved for about 10 minutes. Those students finished the semester 20% earlier than the other classes with 10% higher test scores. Then, the EU delegates reached out to me for the Global Financial Forum on Sustainability, hosted at the UNESCO World Health Headquarters in Paris. They asked me to brief the EU delegates on how to stabilize the European economy and the euro currency. I'm woefully underqualified to do that. But what I could talk to them about was Scrum, so I did. I said, here's the implications of extreme manufacturing, or Scrum in hardware, Scrum in software. And they said, that's it. Our job is to pass legislation that makes it the default for a new company to open to use Scrum, instead of publishing their 5-year made-up Gantt chart of what's going to ship when, which we all know does change, right? So instead have a prioritized backlog of what we think is going to happen and know that it's going to change, and have the law incent that. Cool, yeah, let's do that. Then I went on a world tour working in companies doing hardware and software blended projects, and then banking. Next month, I go to Pictet in Switzerland. They throw a week-long bash for the world's wealthiest families, the 0.001%, and they asked me to brief them on the industry trends that will be shaping their investment portfolios. I'm woefully underqualified to talk to the wealthiest 0.001% of the planet's families on the trends that will shape their investment portfolios. but I will talk to them about Scrum and let them know about how that may impact some of what they care about. The reason why they might care about it is this. Every year, the Standish Group runs a report on project success by process type. The left is a graph of waterfall projects where we do plan in advance. Here's the Gantt chart of when we think we're going to ship. And on the right are agile projects where Scrum teams deliver whatever's most important this week in week-long increments. They can be other length increments, but week-long are becoming the most common. On the left, we see that 29% of waterfall projects studied worldwide were complete and utter failures if they were software, not even one line of code shipped, and all the budget was spent. Green, 14%. We see 14% of those waterfall projects were on time and delivered what they expected with happy customers. Then we have more than half being challenged. The budget was spent, the project did run over, it needed to be refunded, and it didn't meet the goals expected by the customer. On the right, we have agile. We see a 9% total failure rate. Okay, that's 300% better. That sounds pretty good. Then we have a 42% total success rate. Awesome. That's almost half. That sounds perfect until you look at the challenge rate, 49%. 49% of even these miracle agile projects still failed to delight the customer. They went over budget or under-delivered. They then did a follow-up survey to say, what type of agile method did you use? And they found the 49% said, we don't know. The green 42% could say, we used extreme programming practices with Scrum teams, or we used Kanban to optimize our flow with extreme programming engineering practices. They knew they had a system. Oh, some of the 49% yellow teams of Agile said, no documentation. That was their Agile practice. That's not Agile practice. So now we know why these teams would care, and that maybe takes me to what just might be the entire point. If we reduce the cost to make change, we're thinking from an Agile point of view. The definition of Agile is 4 values and 12 principles. That's it. They all point towards making it cheap to change your mind. So you can run experiments each week. So what does hardware, and specifically hardware architecture, look like if we've made it cheap to change our mind? So it doesn't take us 5 to 7 years to have and deploy, to design and deploy the next rev of an automobile. Maybe it could just take us a week to make a meaningful increment of that product. And in fact, that's what we're seeing. So the world is changing right now. It's happening very quickly and in all industries. And what's awesome is we have a room full of software architects and people who care about that. It seems to be the software architecture patterns are verbatim what is now starting to change every other industry. There is no book on hardware design patterns. There are some really good ones on software design patterns. I take it back. The original patterns book was on architecture, building architecture. The type of stuff that applies to houses, sure, which is awesome. But the type of stuff that applies to cars, watches, circuit boards, data centers, not authored. We don't have a library of reusable patterns to deploy. I hope one of you writes the book. I'd like to read it. Team Wikispeed has identified 11 hardware patterns. That's the best we've got so far. They're published on our blog in our Wikipedia article. Join Team Wikispeed. Help us change the world and sharpen your Agile skills with us. Let's deploy solutions like ultra-efficient cars, micro-houses for the homeless, and modular micro-factories to bring the means of production to the point of purchase. If that sounds fun to you, come hang out with us. We do this nights and weekends for fun. If anything I'm saying might affect your work or what you care about, what you're passionate about, all the data is on my works website, scruminc.com, including the white papers and the data points to help you pitch this in your group. You can reach me at all of these addresses, and I hope you have a completely awesome conference refining your hardware and software architecture skills. Thanks, guys.
Thanks so much, Joe. We have about 5 or 10 minutes for questions. So.
Oh yeah, if there are any, I'd be happy to. Also, if you think of it later, you can email or tweet. That's just fine. But if there are questions here, I'm happy to try.
I was curious if you did anything with FedEx Days or that concept to get improvements.
Yeah, so if I follow you, FedEx Days, the idea where you have an innovation time box where people can work on anything, yeah, that's basically the whole sprint, right? So yes, all the time. So Monday through, well, really they start Thursday. So Thursday through Thursday, it's whatever people are excited about, and they put it on the backlog. Now the only difference is, to make it not a complete anarchy and have a single salient vision so the stuff comes together, is at any given time, there's only one person in a role called a product owner. Anyone can put sticky notes on the backlog all the time, which is like the idea of a FedEx Day. I want to work on this. This would be helpful. I think this would be awesome. The product owner is the only person who can prioritize those sticky notes. So they need to write it in such a way as it's going to be meaningful to the product owner's passion or the business acumen that they care about at that time. So it's like a nonstop FedEx Day, but there's a single person at any given time, and that person rotates, that determines the order that things will happen, and it flows through the queue. We don't do any work without a product owner, so we don't have a complete open FedEx Day where people do anything they want. I mean, they can, but then they wouldn't be Team Wikispeed, would they? Because the only definition of work done for Team Wikispeed means it's the top thing on the backlog, and it's done meeting the definition of done for that sticky note. Did that talk to your question, or did I miss it? Okay. Oh.
Yes. So during the portion about the radio manufacturer, you spent a lot of time talking about how they could keep up with Motorola, for example, and maybe be 7 days at most behind in terms of features. But that sounds like fast following. Could you speak a little bit more about how it might help them innovate faster and leapfrog Motorola, for example?
Thanks for asking. So the changes the team or the company makes are any change that they're able to sense are important. So step one is make sure we're not irrelevant for very long. So they can't be more than 7 days irrelevant, right? They can respond to industry changes. But if they have innovators or passionate people with really good ideas, those changes can be posited at the same time. What's interesting is it's the same mechanism for incremental innovation or fast following as it is for breakthrough innovation. You have the smartest people that you're able to grab in your company, now, or in your team or your volunteer organization. They're completely uncorked once a week to propose innovation of whatever the company can do in a week. What it eliminates, though, are grandiose plans that would take multiple year rollouts. That'd be waterfall. Instead, it says, what's the small change we can do next week? And what's interesting is by doing one of those and measuring your velocity and your quality and happiness, and then the next week another, by the time you've completed three weeks, you have a completely different company. And yet it was never a big management shakeup or employee shakeup. It never really stressed out folks like it can happen when we have a reorganization. Did I talk near your question at all, or did I miss the boat? Perfect. Oh, wow, perfect. Thank you.
Are there any patterns that you're detecting in the inefficiencies that you're working out of the processes?
Oh gosh, that's a really good one. Are there any patterns we're detecting? Patterns of inefficiency? Yes. Oh, my goodness. Okay. Each time there's a handoff, one group designs something, but then they're hands off. They don't do the next step. They don't implement, which is very common, right? Many companies are organized that way. There's a silo that does this activity, and they hand that data. Each time there's a handoff, when we do a value stream map of the work, there's a slowdown there and some knowledge loss. If it's responsible or practical to have those same people that did this first piece, like say the architecture, then join the team doing the next piece, and then join the team doing the next piece, it seems to erode that knowledge loss and that time loss. So I'd say architects don't code would be an anti-pattern, I think, from looking at stats of speed and flow and working with these companies. Or folks who do part of any of the implementations and hand it off. Also, when we don't have folks responsible for integrating, the same folks, right? When there's an integration team or a bug bash team, we get a bunch of slowdown and knowledge loss. Here's an interesting observation that will probably lead to a pattern that I hope one of you publishes. The evidence shows that if a bug in software or hardware, so a feature that doesn't work as designed or the customer isn't happy with, is found. If the time to rectify that bug and deploy the solution in hardware or software takes more than a week, the time to fix it multiplies by 4. So if you have something that would be a week-long fix, it will become a 4-week fix if it escapes the sprint. This is just observed from the time it takes to get cards done. So maybe the pattern is make sure we're checking early. Test-driven development catches that for us. If our tests are good, it gives us a better chance of catching it early, and then adjusting right there when we're still designing that thing. Also, if we have silos passing off, well then, of course, it's going to take longer than a week to rectify. So straight math tells us the time to fix multiplies by 4 if we don't fix it that week. So I'm sure there's a useful pattern or anti-pattern there. Did I miss your boat, or was I even close? Okay, thanks.
Hi, so I have a question. So actually two. So one of them, how regulation is getting into the process of Scrum, right? Because a lot of industry requires certain regulation that we need to do, right? And the second question is, what you were talking about is a small team. In a big corporation, you have, I don't know, 6, 7 teams that deliver the same product, right? So how this knowledge is transferred between the team to make sure that it's not a silent development, and how you transfer this knowledge between the team without affecting velocity?
So the first, how to do any of this in a highly regulated industry, right? So there isn't a more regulated industry in terms of number of laws to be complied with than road legal surface automotive transportation. Even commercial aviation is less regulated. It's stringently regulated, but less than surface transportation in the United States. You have the federally mandated vehicle safety specifications, the airbag tests that are implied, the side impact test, roof crash rollover. There's even regulation about how the locks need to work to prevent theft. Makes sense. So those all become stories in the backlog. This needs to be met, and we flow through that work. The way we started is each one of those tests, and if we printed them all out, it's about that thick. Chapter 49 of the federally mandated vehicle safety spec. They started as red sticky notes all across the wall. And so we have this wall of red, and we didn't know how to do it, right? And then we'd take one and try to replace it with a green sticky note, saying we have a version that passes the test. It might not be robust, it might not have the abilities that it needs yet, but it passes the test. We have a prototype. And then we'd refactor and improve it, make it more robust, and go through, and we could visually see how closer we are to shipping road legal. That is how we coped with regulation. It worked well for us. I'm sure there's other patterns. I'm glad to share one that we bumped into. Then for sharing information across teams, say you have more than a project that might need more than 5 people, even if they're moving 10 times as fast. Well, that'd be like a team of 50 people now, but say it's a product that requires 500 people now. The largest implementation of this I'm aware of right now is at SAP. There are more than 1,000 teams doing this in software, side by side, more than 1,000 Scrum teams. They use Scrum of Scrums, and I don't mean to get too detailed, but hopefully enough that you have something actionable if you want to try, is each Scrum team only has 3 roles. There's the product owner, and there's only one. And their job is to make sure the backlog is in order and prioritized. They have a few other jobs, but that's the most important one. Then the Scrum Master, it's their job to make sure it's published and visible what the velocity of the team is, so we know as we tune, are we going faster or slower, and the team's quality metric and happiness metric. Then they do anything they can do to speed up the team. They post impediments, they go ask other teams for information, etc. Everybody else is the team. As far as Scrum's concerned, we don't need titles like junior this, senior that, anything. I mean, you can have them for HR reasons, that's fine. Scrum says you don't have to have them to get the work done, you just have the team, and it works. Across teams, the Scrum Masters meet every day. They have a summary with the team called a daily stand-up. What I got done yesterday, what I'm going to try to get done today, and what the order we're going to attack this to get it done should be to get it done as fast as possible. 15-minute meeting every day. That's it. That's the only meeting during the sprint week. There's one day for planning the next sprint. During the sprint, 15-minute meetings every day. After that meeting, the Scrum Masters all meet, and they do the same thing. What did my team, in summary, get done yesterday? What is my team working on today? What's blocking or slowing down my team? Or what did we do recently that worked well to speed up my team? This also clarifies the I/O between the teams. My team got this from your team yesterday. We did this and it's not working so well. Help us. Come over and visit for half the day. That distributes that information. Well, you wouldn't have that next meeting with 1,000 people if you had 1,000 teams. It scales, gosh, the buzzword is fractally. What that means is one team might be involved in a particular discipline. And they might have 10 teams that meet in their scrums. That one team then comes to the next scrum of scrums. So different than hierarchical, because one team might just have one team that rolls under them, another team might have 10 or 100, and you end up having usually less than 5 scrum of scrums, and so in less than an hour, the entire company every day is in touch with each other and passing best practices back and forth. That might sound more complicated than it is. It's really groups of 5 people standing in a circle for 15 minutes or less, saying what I did yesterday, what I'm going to try to do today, what's blocking me or slowing me down. And then one of them goes and gets in the next circle, and they do that again. And then maybe they need to do that again, and you've scaled it across 1,000 people. So it's maybe simpler than it sounds. Did I get anywhere near what you were asking, or did I miss the boat? Close? Okay. You can send me an email or a tweet. And if you tweet, it might be even better, because someone on the team might answer, and they might have a more articulate answer. Folks, thank you very much. It's an honor that you thought
Joe,
this guy could
thank you very much.
For a minute. I appreciate it.
Round of applause for Joe. And we have a token of our thanks from Carnegie Mellon SEI, so thank you. Diana promised a talk that would be lively and would keep everybody awake after lunch, and I think we succeeded. So thanks, Joe. We have a session starting in the other 3 rooms almost immediately, so we will see you later. Thank you.